The fundamental counting principle can be seen throughout mathematics in a variety of areas. In statistics, it allows you to calculate the total number of outcomes possible for a given event. More specifically, if event A has m outcomes possible, and event B has n possible outcomes, then their product m times n tells us the number of ways or the number of outcomes that they have together. So in this example, we have a 5-digit security code for your ATM card. The requirements are that the first digit is not either a 0 or a 1, and you are not allowed to repeat any of the digits. We want to find what the probability is that a thief will guess your PIN number on the first try. So the first thing we need to do is to figure out the number of possible 5-digit PIN numbers for this specific scenario, and each of the individual digits is going to be its own event. So if we consider the first digit can either be a 0 or a 1, and there are 10 individual numbers between 0 and 10, then that leaves us 8 possibilities that we can choose from for our first PIN number. Then we can move on to our second digit in our PIN number, and since we're not allowed to repeat any of the digits, when we started off with 10 and we took 1 away from the first one that we used, then for our second digit we only had 9 options left. As you move down to each of the individual digits, you will have to decrease your number of options for each of those events by 1 because you're not allowed to repeat any of the digits. The number of possible 5-digit PIN numbers is then 24,192. Now we want to find what is the probability that a thief will guess your PIN number correctly on the first try. There is only one possibility out of these 24,192 that is your PIN number. Notice on our calculator that we have this weird number, 4.13 e to the negative 5. The negative represents that a decimal point should actually be moved to the left this many places. When you see this on your calculator, it just means that you have to physically move the decimal point this many places in this direction so that way you could see the correct decimal that you should be rounding. Moving the decimal point 5 places to the left and including zeros in those correct place values now shows you the decimal. We can then round this to our proper place value, which is still 4 decimals in probability unless otherwise noted. Notice how even though your probability is approximately 0, we still want to write this as 4 places to the right of the decimal to have this written as proper probability notation. In conclusion, the more difficult your PIN number, the more difficult it is for a thief to be able to guess it correctly on the first try.